Work it, make it, do it, make sense.
Good morning, everyone. Welcome. You're the most organised audience I've ever seen. You like shuffled up, made space for everyone, using up all the seats. That's fantastic. I've never seen that before, and I've been to a bunch of conferences. Well done. Yes, hi, I'm Trisha. Only one or two of you want to know about Java 9 then. This isn't alarming at all. I'm a technical advocate for JetBrains. I work mostly with IntelliJ IDEA. Anyone using IntelliJ IDEA? All of you. I love you all. You're fantastic. Any Eclipse users? I'm so sorry for you. I also work with UpSource, the code review tool, but most of my job is kind of doing research into what's coming in Java or what's kind of currently interesting in Java, and then figuring out how to apply it to kind of your day job, basically, because I was a Java programmer for about 20 years, and that's quite frightening. And you know, people always tell you about new and exciting stuff, but that's not so relevant to what you're doing in the day job unless someone makes it more applicable to you. So that's kind of how I see my job, if you like. So today we're going to talk about real-world Java 9, which is great because Java 9 isn't out yet. What I really want to cover is a little bit of Jigsaw in action. Who went to one or both of Mark's sessions at the conference? That's great, because I don't want to repeat a lot of the stuff that he said. I just want to give a sort of high-level look at using Jigsaw. I'm going to cover a bit about reactive programming in Java 9. Oh, by the way, Mark is in my audience. Please don't shout at me if I get it wrong. And I also, what I really want to do, and hopefully I'll have time, is at the end, a good chunk of time will be going over all the other features in Java 9. Well, not all of them, but the ones that I think are going to be relevant to you in your day job, so the kind of interesting stuff to us as developers. Firstly, let's step back and take a look at why we care about Java 9, other than it's new and exciting, and obviously we want new and exciting. From my understanding, and of course you have to bear in mind that no one, I hope, no one is using it in production yet. The idea of Java 9 is you'll get a bunch of stuff for free. You'll get better performance, better use of memory. It uses new CPU instructions, things like that. So you should get things like performance improvements and generally a better experience from things like the compiler without having to use any of the new features. So this is a good thing. Let's look at the elephant in the room straight away. Most people, when they talk about Java 9, they mention Jigsaw, particularly if your name is Mark Reinhold. And so this is kind of the big feature for Java 9. And, well, I don't know. I was going to say, it's perhaps not super exciting to us as developers, but maybe we'll get onto that. So you hear about Java 9. You might hear about the REPL. Who's heard of the REPL, JShell? Fantastic audience you are. So that's maybe more than half of you. So the idea of the REPL, who's used a REPL in another language that isn't Java? I don't know if that's the same set of people, but it's a good chunk of you. For most of us who've been doing Java, and only Java for a long time, the REPL is kind of an interesting and new idea. The idea of being able to execute small snippets of code from the command line and try stuff out. This is quite good for sort of introducing yourself to the language, but it's also quite good for like trying out bits and pieces to see how things work. And I think this is an interesting idea for Java, because in the past, you know, we're accused of having quite a lot of boilerplate. I don't know why they're saying that when a simple hello world application is only 24 lines of code. But the REPL will help us try stuff out without having to have all of that boilerplate. But we're kind of left with this question of, OK, we've got the REPL and Jigsaw. What else is there? Is there anything that's kind of interesting to me as a developer? But it turns out, like in Java 9, there's one or two things going into the language. Some of these aren't necessarily going to be visible to you as developers. There's a lot of stuff that's gone under the covers. Obviously, there's things like modularization of the JDK. There's things like updated logging inside the JDK. Things like, I think they wrote a bunch of performance tests and stuff like that. So that's not necessarily visible to you, but you should benefit from it in terms of it being a better written, better designed language. But there are some other bits and pieces in here that I want to take a look at the end of, well, at the end, maybe about a third of the way through the presentation, and see which things in there might be most applicable to us. As usual, I like to set my expectations for this talk appropriately low, since there are about 500 of you in this room. Of course, you should not be using Java 9 in production. Please don't do that. It's not ready yet, and it does change from week to week. So it's, you know, every time you download the latest version, there are some changes in the way things work. So don't use it in production, but do have a play with it, definitely. It's ready for trying out. Speaking of which, everything is early access. So again, setting expectations appropriately low. I'm using an early access version of Java 9. I'm actually using build 166. I think the most recent one is build 168. But build 168 doesn't play nicely with the most recent EA build of IntelliJ IDEA, so you have to get sort of the right combinations of the early access things in order to try and get things to work properly. So I'm using early access Java 9 and an early access build of IntelliJ IDEA 2017.2, which the early access only came out like last week, so it's in the very early days. I won't use the word unstable, but I will say it's always interesting. And of course, with Java 9, we really don't know what best practice looks like yet, because we're not using it. We're not using it in production. We're only just starting to get an idea of what best practice might look like in terms of Java 8 with lambdas and streams and things. So I can't really tell you, like, this is the way to do stuff, Jigsaw-wise, because we won't really know that until it's sort of bedded in and people start using it a lot more in anger, if you like. Let me set the background for the case study we're going to look at. At DevOps UK, a couple of years ago, I did a demo, Java 8 in anger. I wrote this application to demonstrate Java 8 features like lambdas and streams. And the idea is it's a JavaFX UI which responds to real-time tweet data. And it also happens to be architected with lots of tiny services that might be micro-sized. But they're not microservices because they're not reliable. They fall over all the time. There's no monitoring or any of the stuff that's actually appropriate to microservices. But the idea of this application was to use Java 8 features to architect something which is kind of running as lots of independent services and react to real-time data. And it turns out that this is quite a good example to use with Java 9, particularly when we're looking at things like the Reactive Streams API, which is something I want to go into in a little bit of detail. If you're interested in the original application, I've got resources for that specifically. So I'm not going to go into all the ins and outs of what it does and why it does it, because I already have a presentation on that. So first and foremost, by the way, I've only got like 50 minutes to talk about all of Java 9, so I'm going to talk quite fast. I do apologize. But I'm in London, so I feel comfortable doing that here. Next up, yes. So I think probably, if you read anything about Java 9, if you read stuff in the news, you might get a little bit alarmed by some of the scare stories of everything is going to break on Java 9. So the first thing I really wanted to do is take an application like my application. It's small-ish, as in small enough to get your brain around it, but complicated enough to do something interesting. And I want to compile it with Java 9 and see what breaks. And that way we can get an idea of what potential problems might exist. So let's try and get this running. Oh yeah, the first thing I want to do is I want to see it running at the beginning just to make sure that everything's working to begin with, because if it doesn't work before I start refactoring it to Java 9, there's zero hope for the rest of the demo. So as I said, this runs as a series of independent services. I've got one service which kind of acts as a Twitter service. It's reading tweets from a file to make life a bit easier. I've got one service which is extracting the username from those tweets. I have a mood service which is not starting. Let's try that again. I have a mood service which looks at the tweets and extracts whether the tweet is generally happy or generally sad. And I have a dashboard which is showing me those results in real time. Yeah, look at that, an exception straight away. I think that's because I started the dashboard before I started the mood service, hence my comment about lack of reliability. It's kind of working. All right, there we go. So yes, so it works before I refactor it. That's a really good start. And right. Now I'm going to see what happened the first time I compiled this application against Java 9. It was obviously a Java 8 application. So let's take it back to a version which, before I started doing the Java 9 migration. So if I build this, there we go. So there's a few things. I did insert a couple of things to fail on purpose, but most of the stuff that failed was already there. Firstly, you can't have underscore as a valid field name. Now, people might think, I didn't know you could do that. That looks exciting. I can use underscore as a valid field name. Up until Java 8, you could use underscore as a valid field or parameter or variable name. But in Java 9, in Java 8, you'll get a warning. In Java 9, it's not going to work anymore. So don't do that. There's a fairly easy fix. Something sensible. And away you go. And the reason being, they're going to use underscore as something interesting in later versions of Java, so that's kind of cool. But in the meantime, obviously, we have to get rid of it from our code bases. One of the other things is, let's take it out of presentation mode. So, of course, as we always hear with Jigsaw, that one of the ideas was to encapsulate the internal APIs. You shouldn't be accessing anything which is like sun.misc. And I wrote this application knowing I shouldn't access sun.misc, but being too lazy to figure out what the right way to do it was. So I was using the encoder, and now under Java 9, of course, it doesn't compile. This fix turns out to be fairly easy because there's a simple replacement for this. So here, instead of using my base64 encoder, I use base64, java.util, get encoder, encode to string. So I can just replace that. And then everything compiles. If I build everything now, my whole application compiles successfully. So for me, it was fairly painless to convert this Java 8 application to use Java 9 without using any of the new features. There were some problems, but nothing too show-stopping. So that's not as bad as I thought it would be. What did I do with my remote? Here it is. So when I created this presentation, I didn't actually want to talk about Jigsaw at all because, for a start, there are going to be lots of people doing talks about Jigsaw. It's going to be the focus of sort of a lot of the Java 9 presentations, and it's quite a big topic. You can't just kind of mention, oh, and by the way, Jigsaw. But it turned out that I ended up playing with Jigsaw anyway to figure out, like, how it's going to look for me in a fairly small project, but also mainly because Gradle doesn't work with Java 9 at the moment. This week, on Monday, I did get it to work with Java 9 with a bunch of set compiler flags, and I had to run it without the daemon, and I had to run it from the command line. I couldn't run it from inside IntelliJ, and there are some things you can do to get Gradle to work, but I could not get my project to work inside IntelliJ with Gradle in a multi-module project. And the whole point was this is a multi-module project, so I kind of wanted Gradle to work, but it also means that I can perhaps start playing with modules. So what I did was, so the directory structure we've got here is a sort of fairly typical Gradle type directory structure where I have, I've got a laser on this. That's really silly. So I've got a couple of different modules, and the modules have got source main Java, source test Java inside it, sort of fairly typical groovy Gradle structure. What I ended up doing when I started playing with Jigsaw, I changed the structure of my project to follow more closely what it's suggested in the tutorials. And here that meant I had source and then all of my individual modules inside my source directory, and test and all my individual modules inside my test directory, which was kind of inside out from what I had before. And this mirrors what's inside the OpenJDK, so I kind of wanted to follow that. But this was a non-trivial thing to do, to rearrange your whole thing, just so that you can put some module info files inside your modules. I have got it to work with the Gradle structure as well, so it's not a mandatory part. But if you're following the tutorials, you'll see a directory structure which is different to what you're used to. It's different to the sort of groovy way of doing, the Gradle way of doing stuff. So in my production code, I've added a module-info.java magic incantation file into each of my individual modules. You'll notice that I don't have them in my test directory. And this was a pragmatic choice, I won't call it a hack, a pragmatic choice to get everything working inside IntelliJ IDEA because obviously you can't have modules with the same package names in two different modules. So I can't have a test module and a production module. There is a way around that using Jigsaw, but I didn't have the time to get that working, so I chose this as a pragmatic approach for the demo. There are, of course, some trade-offs with this in that, for example, I can only run the tests from inside the IDE. Also, because I'm not using Gradle anymore, I also manage my dependencies from inside the IDE. So this is not really a sort of production-ready system as it stands right now. But what I did find when I was doing this whole process of modularizing my code is my original module structure was kind of naive, shall we say. So I've got two back-end services, and the code for the back-end services depended upon the code for my Twitter service. Now, that doesn't make any sense. I can listen to the Twitter service, but I shouldn't be dependent upon the code in the Twitter service. So by looking at my dependency structure, by looking at modules as a sort of first-class citizen, I realized I kind of modeled my application incorrectly. I also noticed that the client code was dependent upon the WebSockets API, but nothing else was, which is kind of weird because they're all using WebSockets. And my Reactive Streams API was being used by two of my modules, rather than either all of them or just one which manages the API side of stuff. So I kind of had a bit of noise in there, which it just felt a bit wrong, the way that the code had been organized. So when I was thinking about what my modules really were and how to encapsulate the code, what my dependencies should really look like, I rearranged a lot of this. So now all my services are kind of at the same level. They don't depend upon each other code-wise, so that feels much more correct. I have a module which is the sort of reusable service code, which is dependent upon by all the services. That makes sense too. And this is the only one that cares about WebSockets, because this is the thing which hides away the implementation, which happens to be WebSockets, from the actual services themselves. I also have all the back-end services dependent upon my helper module for the Reactive Streams API. So that's cool because they all use Reactive Streams. And then I have two services which use RxJava by choice, and one service which uses Reactor, because I wanted to show that you can use different implementations of the Reactive Streams API, which we'll look at a bit later on. So I was much happier with this module structure, and by thinking about modularity and thinking about my dependencies, I came up with a much cleaner design for my application. So let's take a look at what's involved with creating a module info file and what that sort of means. I know Mark covered this in his talk this morning, but I'm going to do it from inside the IDE because that's what we really do in the real world. I was really impressed with Mark's command line foo. I just don't work that way at all. Right, so let's switch to the right branch. Okay, so you can see here I've got my modules. Let's put this in. So you can see that a bit better. And what I've got is, in most of my modules, I have the module info file. I have a module which I haven't converted into being a Jigsaw module yet. So what I need to do is I need to create a new module info. IntelliJ makes a reasonable guess as to what the name of that module should be, and I'd like to keep it like that. You can't really see that very well. So by doing that, by adding my module-info.java for this particular module, I start to magically use things like module path, and I'm doing things the modular way rather than the old way, which is the way that we're doing it right now. So now when I compile that, I should get some interesting errors. And what we see is, inside this module, one of the classes now, which was compiling fine before, now it says the module sense.flow does not have the module java.logging in requirements. Obviously, because I'm using IntelliJ IDEA, I use Alt-Enter to magically fix my problem. And what we see is module info now we have requires java.logging. So by default, it's going to be able to see everything from java.base, but not all of the other modules inside the JDK. So you have to go in and declare which of the modules you need to use. You can do that either by auto-fixing stuff, or obviously you get some nice, happy code completion for all of your Java modules there. So now that that's not erroring, what's our next error? So we have a similar problem here, only this isn't from inside the JDK. This is an external dependency on an external jar file. I need to add that library to the class path for idea. And then I need to say add requires reactive.streams to module-info. So I do the same sort of thing. Now we have two different requires, one from inside the JDK and one which is using automatic modules. So it's going to use the external jar file there. And then those errors go away. What's our next set of errors? Now from outside, from a different module, I get the error is sense.flow does not export the package sense.flow to the module sense.user. So now this is complaining about the fact that some external module is using something from inside this module. So this module needs to declare what other modules can use. So I'm just going to export my package there. And then everything should just work. So that's kind of fine, and that's okay for a small little module like this. There's not much going on in there. There's a requires, there's an exports, and that could sort of fairly easily be fixed up by sort of addressing each error by error. I'll show you some of my other module infos, which cost me slightly more to do. So this is the UI. Here you can see that I require a bunch of the JavaFX modules and java.logging. JavaFX uses reflection, so I had to open up my pretty much all of my code to JavaFX for reflection. Now I explicitly decided to just open it just to JavaFX, and I want to open it to everything to be able to access me. I also have to export. This was interesting. A lot of these kind of came up as errors while I was compiling and while I was running stuff. So I was just kind of like hacking away to try and get it to work. It turns out that when I showed this to someone from inside Oracle, I shouldn't have to do that. And there's actually a bug raised within the JDK as to how they're going to address this. So this is the way that JavaFX happens to do its sort of reflection over your code. That's the magic incantation I needed. And now it all works. Another one, let's look at service. This one uses a whole bunch of stuff from external jar files, so a lot of these are automatic modules. I found this by trial and error and brute force because I'm stubborn, but I would suggest you read the documentation for the JDEPS tool and use that, because it takes way less time than restarting your application all the time and figuring out what these errors mean. So yes, do read the manual. It's very useful. So that's what I had to do to kind of get my application to be more modular. It is a smallish application. It's not like these massive enterprise applications. It took me about a day and a half to get that all running and working. The pain I found was mostly the fact that Gradle doesn't work. And I spent another day this week trying to get Gradle to work. So Gradle doesn't work with Java 9 right now. I'm not sure about the state of Maven. I think that works under certain circumstances. I think Gradle works if you don't have a multi-module project, but kind of a lot of us are working with multi-module projects. If you decide to reorganize the file structure, that's a non-trivial task. I would not recommend doing it unless you absolutely have to. And of course, the way that I've got this to work is there's no command line build for this. There's no way of running the tests inside a CI environment or something like that. One of the other pains is that the IDE support, there is IDE support for things like Jigsaw. As you saw, I've got some auto-completion, I've got some quick fixes, I have some help there from the IDE, but I don't have like a magic generate me my module info type button. I don't have some of the other things which might make my life a little bit easier. I don't get quick fixes for everything. So we are working on that, but what we need from the JetBrains IntelliJ IDEA side is that if you find pain working with Java 9 in IntelliJ IDEA, we need you to report that to us so that we can fix it, basically. And do your homework. If you're going to do this, particularly Jigsaw, do a lot of reading, figure out how the tools work, figure out how the stuff works from the command line before diving into the IDE, because otherwise you don't really understand what's going on underneath the covers, and it can be quite painful. Right, I want to move on and talk about the Reactive API, because this whole talk was supposed to be about, oh, Reactive is good, and here's how you do Reactive in Java 9. There exists a Reactive Streams API, currently in Reactive Streams 1.0. This has everything you need to define the sort of API between two different reactive programming libraries. So obviously you have a publisher and a subscriber. I don't want to talk too much about what Reactive Streams really is, or asynchronous programming or anything like that. I just kind of want to skim over the surface of it and sort of show you how it works in anger, really. So with the Reactive Streams API, we have a publisher, we have a subscriber, we have a processor which combines the publisher and subscriber, and a subscription which kind of helps you to manage the relationship between the publisher and the subscriber. Implementations of Reactive Streams include things like Akka Streams, Reactor, RxJava, Vertex. So a lot of these popular libraries for doing reactive programming in Java and other JVM languages, in fact, it's not just the JVM languages, they implement this API. So that's quite nice. They can talk to each other without really caring about their own implementation. They're talking over the same API. So for this reason, in Java 9, we have got the Reactive Streams API built into the library. Now, I think this is a really positive thing. I think this is great. I think reactive streams and reactive programming is a good model to follow. It's quite a nice way of doing asynchronous programming. It's not as complex as other models. And the fact that this comes as part of Java 9, I think, means that we are kind of embracing it as a Java community as a way, one of the ways of working. So this is great. The only downside is that, of course, the Reactive Streams API is actually different to the Java 9 API. The API itself is not. The interfaces are called the same thing. The methods are called the same thing. They have the same signatures, but they're in a different package. So at the moment, they're not really reusable. So if I'm using RxJava and I'm getting a publisher, I'm getting an org Reactive Streams publisher. I'm not getting a Java util concurrent flow publisher. So for this demonstration, I actually wrote an adapter just to wrap those things and convert them from one to another. But that's one of the things which I think is interesting to understand, because the libraries at the moment are going to be using the Reactive Streams API, not the Java 9 API, obviously, because they're not compiling against Java 9 yet. So where do you want to use something like a reactive API? In my application, I designed it to be sort of event-driven, so it seems like quite a good fit for the Reactive API. I have really stupid services. They use WebSockets. They take a string off a WebSocket and put a string onto the WebSocket. And then I have, obviously, some business logic. This basically is the architecture diagram for everyone's application ever. But I had really simple business logic, because for a number of reasons. One, it needs to be an approachable, understandable demo. Two, I need to be demonstrating Java 8 features. So my business logic is, generally speaking, a lambda expression, which maps a string from one value to another. So in the case of the user service, it takes a whole JSON representation of a tweet and returns a username, for example. And so this looks like you pass in, the signature is, I'm going to take a function, which is my business logic, and to take advantage of that, I pass in a lambda expression or a method reference, which represents the business logic of my service. So given this, my services, as I said, are sort of intentionally quite stupid, but I can make them a little bit smarter by exposing the Reactive Streams API instead. So what I sort of figured is that actually, from a business logic point of view, I could be listening or subscribing to a publisher, which is going to give me a stream of messages, and I can be sort of sending those messages to something which subscribes to me, to a subscriber. So I'm going to change the shape of my overall service so that I have a publisher, which publishes strings in my case, and a subscriber, which listens to the result of the business logic. So, so let's take a quick look at what that looks like. So in the case, let's go back to the diagram. The publisher, in my case, is a class called client endpoint, because what that does is it listens to the WebSockets and then publishes some string value. So that's client endpoint. So what I need to do is I just make client endpoint implement flow.publisher. And then what it needs to do, once you implement flow.publisher, you need to implement subscribe. And the subscribe method takes a subscriber, and then you're going to do something. So as a publisher, what I care about is who is subscribed to me, and then I will do something with those subscribers at a later date when I need to. So I'm just going to manage those subscriptions by keeping them in a list. So Java 9 provides the interfaces for the Reactive Streams API. You don't need to implement them with your own implementations. The idea is that you're going to use an implementation like RxJava or Reactor or something like that. But for the case of my services, because they're very, very stupid, I actually decided to implement my own publisher. So that's the choice that I've made here, but not necessarily, definitely not something I would recommend. Because there's plenty of frameworks that do all this stuff. But I'm going to manage my own subscriptions from this point of view. On the other end, the subscriber, in my case, is a class called Broadcasting Server Endpoint. And what that does is it listens to stuff from the business logic and then uses WebSockets to send that to whoever cares. So again, what I've got is I'm implementing subscriber. And subscriber has onSubscribe, onNext. OnNext is the interesting thing. That's like, what do I do when I'm given an event? OnError and onComplete. So those are the things that I had to implement in my class. So on subscribe, all I'm going to do is I'm going to say, give me everything that you get for the end of time. What you can do if you want to is you say, I only want to see the first 3 messages. But in my case, I'm just going to always listen to what the business logic sends me. On next, and what I need to do is I need to listen to all the sessions. For all the sessions which are listening to me, I need to send them that message. On error, may I suggest that you do not do this? Error handling in asynchronous systems is a very interesting situation, and I did a lot of simple error handling in terms of for getting the demo working. I did a lot of print stack trace and things like that. Do not swallow errors in an asynchronous system because things will just not work and you will have no idea what to do about it. Error handling is a first-class citizen of asynchronous systems, and it's really important to understand what to do with them. So don't do that. And then do something on complete. So I need to close my WebSockets when there's no more messages. So it was fairly straightforward for me to use the Reactive Streams API to provide a simple API for anything that wants to basically create a new one of my services. So what does that mean? Like, how am I going to use this API? What's the point of having a reactive API? And so the first thing I'm going to look at is I'm going to look at my tweet service. How can I now make use of a reactive programming framework in my tweet service? How does that change things? So what I had before, and I've mentioned this a few times, is that the aim was to demo lambdas and streams. What I had before is I had this really nice feature of Java 8 where I use files.lines to get a stream of strings. For every line in a file, I will get a string back in a stream, and then I can do something with it. So what I'm doing is I'm reading a file of tweets, and then for every line, I'm just kind of emitting that to anyone who cares. I have to filter out some noise in this file, and then the other thing I do for the purposes of the demo is that I insert a 100 millisecond delay so that you can see something interesting on the UI. Again, do not do this in production, but from my point of view, as a demo application, this is actually part of my business requirement. You need to be able to see the tweets ticking over at a regular interval. So let's rewrite this using reactive streams, because we can. So I'm going to use RxJava for this, flowable. So that's adding RxJava. I need to add requires RxJava to my module-info because we're Java 9 now. And then I'm going to say from iterable. I don't get to make the most of the nice files.lines features in Java 8, but I do get a chance to do something fairly similar. And then I can basically just lift the same functionality from here and add it onto my reactive streams. The only difference is there's no such method as peek, so I'll use a method called doOnNext, which does basically exactly the same thing. So I can use reactive streams to do the same thing that I was doing with Java 8 streams. We will discuss the wisdom of this later. So, as you can see, it looks more or less the same. I can just delete all of that, restart my service. And everything works the same way it used to, which is not a massive surprise because the code looks almost exactly the same. So you might be thinking to yourself, well, what's the point of that? Now I've basically added another external library, an external dependency to do exactly the same thing that I did before, and I have a slightly uglier way of creating my streams. Well, reactive streams gives you a bunch of features you don't get with Java 8 streams. So, for example, this thing always made me quite uncomfortable, this idea of like shoving in a 100 millisecond pause, especially using the peek method, because peek is just generally a sort of debug method to allow you to do something on anything which comes through the stream. So this feels like a little bit of a hack. With reactive streams, you can do things like you can create a flowable for an interval. So I can create a flowable which is an interval of 100 milliseconds. What this is going to do is, let's call this tick. This is going to emit a long value every 100 milliseconds. It's just going to tick over every 100 milliseconds. So that's quite nice. And then what I can do is I can merge that with my with my reactive stream for reading the file. So I can zip these two things together so that I can force this stream of reading things from the file to emit things every 100 milliseconds. And this is fairly easy. I just have to say, zip with, give it the tick, and then I have to tell it, given that I now have two values, I have a long value from the tick stream, and I have a string value from my file reading stream, but I don't care about the long value because it's just a placeholder there to sort of tick over. So I'm going to just emit the string value. And then this way, I'll restart this. I've used this feature from reactive streams, which is the ability to actually work on two streams and merge them together to give me something which does the same thing as before, but I think it's quite a nice, elegant solution to prove that this is meant to happen. It's meant to tick every 100 milliseconds, rather than using a slightly hacky approach. So that's a feature of reactive streams you don't get with Java 8 streams, for example. Okay, what else can we do? Oh, we won't do the user service because it's not very interesting. The mood service, let's look at the mood service. 13 minutes left, okay. Let's quickly look at the mood service. So here, what I did with the services, as you saw, I exposed a publisher and a subscriber to anything which is going to use these services, and then I just have to tell it what to do with those things. So let's say I want to get moods. The publisher, subscriber. I'm going to use Reactor to kind of show that you can use different implementations of reactive streams. This, instead of using flowable, I have flux, flux from publisher. Now I'm going to get an error here because from publisher is expecting a reactive streams publisher, and I'm passing it a flow.publisher. So I have an adapter to do that. So that's all I'm just going to wrap it inside my adapter. And then what I can do is I basically do the same thing I was doing with Java 8 streams. I can do it with reactive streams. Flat map, of course, is different because I can't take a stream. I have to have a flux from array. And then everything works exactly the same way it did before, which again sort of begs the question, what's the point? Well, the point is actually when, and I can't collect because, I'm surprised that compiles. I can't collect, I need to subscribe. I'm going to put the subscriber onto the end of that to listen to that, which also needs to be wrapped inside the adapter. 2. So again, this looks exactly the same as the Java 8 streams. What's the point? The point is that actually if I run this, it doesn't work. Nothing happens. It stops. And this was a mystery, especially as I had overridden all of my error handling with, oh, do something at this point. And it turns out that reactive streams are an entirely different model. They work in an entirely different way. They're designed to work on infinite streams. They're designed to be combined. They're supposed to be split. And they have the idea of back pressure as a really important first-class citizen. So with back pressure, if your publisher outpaces your consumer, you have to explicitly tell the system what to do about that. Are you going to drop messages on the floor, or are you going to apply back pressure and force the producer, the publisher, to slow down? So you have to understand how the flow of information works through your system. And if you don't, things just fall over. In this particular case, it turns out that flatmap spawns off a whole bunch of different threads to deal with flatmap. Now, this doesn't happen in Java 8 streams, because if you're not going parallel, it just does everything in a single operation as a blocking, single-threaded operation. And that's a completely different model to the reactive streams thing. So I had to put in a magic incantation to say, only run that on one thread, and then everything works. I would love to be able to give you some detailed information as to why that is, but to be honest, I don't know, but it works now, and that's the important thing. The important message here is reactive streams are not the same as Java 8 streams. Java 8 streams are a very nice way of querying collections in a way which is scalable. If you use the magic parallel incantation and your collection is big enough and your operation is expensive enough, you can spawn that over multiple CPUs, and that's good. That's not the same model as reactive streams. It's not for doing the same thing, even though the API looks exactly the same. It's very confusing. All right, so I've got 9 minutes to go over everything else, really. I'm not going to go into the details of this because it's not that exciting. Yes, so reactive streams look exactly the same as Java 8 streams. They are not the same. Every time you look at reactive streams, you get these really intuitive marble diagrams that I don't really understand, that show you events that go on one stream and events that go on another stream. The streams don't cross the streams, and you have no idea how they're supposed to interact with each other and which direction time goes in. But other than that, it's a really clear way of explaining how reactive streams work. Reactive streams work with multiple streams. You can have multiple consumers. Back pressure is really important, and they have a very different concurrency model. So if you are thinking about going reactive and you have not already done so, you need to understand these things. Otherwise, things are going to go very confusing very quickly. Right, other Java 9 features. Good, I've got a whole 9 minutes to work on this. Convenience factory methods for collections. Has anyone heard of this? A few people. My personal opinion is that this is going to be the most used feature of Java 9. And it's a really silly one as well. Silly. It's a really useful one, but it's not as exciting as lambdas and streams. Let's look at, in the olden days, i.e. now, you create, let's make this a list, okay? Let's make this a list of strings. And you'll create a list of strings by doing something like arrays.asList. So that's how we create a list of strings. That's fine. In Java 9, you'll be able to say list.of. You've just saved yourself something like 4 characters. Yay! Life is good. That's not super exciting. It's kind of nice. It looks a bit better. But what is kind of more interesting from my point of view is you can do the same thing with set, which you could not do before. So you can do this for creating unmodifiable lists and unmodifiable sets of data. So if you're going to set something up just once and then use it throughout your application, so obviously I can see this being super useful for tests. But also, this is production code here. Well, it's sort of test data. But you quite often might want to set up just a small collection that's going to be unmodifiable, and you want to do that as easily as possible. So this is kind of fine here. Where it's kind of more interesting from my point of view is where we look at maps. So again, this isn't a false example I put in here just to show Java 9 stuff. I needed to do this in order to set up a static map with a set of values that I'm going to use to compare stuff. And so I had to have this horrible static thing in here in order to set up the map. And it's horribly ugly. But it's not uncommon. We've had to do this a lot. Now we don't need to do this. We can say map.ofEntries. And so now we can do it with map.ofEntries. So that's kind of nice. We've saved ourselves some lines of code. We don't have to use a nasty static block. And I can see for sort of test data, this could be really useful. It's even more useful if you have fewer than 10 entries, because you don't need hardly any of this. You just say map of. Get rid of all of that. And just do key value, key value, key value for up to 10. So given that I used to work for MongoDB and most of my job was writing maps inside Java, this is super useful and just gets rid of an awful lot of boilerplate around creating maps and other collection types. So I think this is going to be extremely valuable. It's not quite as pretty as Groovy's way of doing it, for example, but it is a good compromise compared to what we were doing before. Right, 5 minutes left. There will be no time for questions. I do apologize. Right. Private methods on interfaces. Now, this might seem like a really silly thing, because interfaces are supposed to define your public API. Why would you need a private method on an interface? Well, of course, the answer is that in Java 8, we got default methods and static methods on interfaces. So, for example, again, this is some genuine code that was in this application. I have static methods, but I've got copy and paste coding in here because there was no other elegant way of doing this. I mean, I could extract this out into a method, get value for field. Oops, it's got value wrong. But this, in Java 8, this still has to be public, and I might not have wanted to expose this on my API. Of course, now in Java 9, I just make that private, and then I can reuse that code. So that's going to be really useful if you've started using static or default methods on your interfaces. I'm sorry, this spelling mistake is really killing me. Value. Feel better now. New methods on the Streams API. The Java 8 Streams API does allow you to work with infinite streams, but quite often doesn't let you stop your infinite stream, which seemed like a tiny miscalculation. But now you have new methods on the Streams API to allow you to do some operation until something is true, or to ignore a series of values until some value is true. And it's called take while and drop while. So, for example, I was using filter in this case because it kind of works. I was trying to do something for a certain set of values, but now I can just say take while. So while some criteria is true, then I want you to do something. And in this case, my stream is only 17 things long, so it's not a big deal. But obviously, for things like infinite streams, you're going to want to do something until some value and then stop. I did get bitten by this before Java 9 came in, because when I was reading my file of tweets, I had no way of terminating that service. It's just going to go until the end of the file. There's no way to say stop now. So this is going to be really useful. So take while is do something until some criteria, and drop while is ignore everything until some criteria. And I believe you can combine the two. So you could say, like, ignore all of these, do something with these, and then stop at this point. It works particularly well on ordered streams, but it doesn't have to be just ordered streams. The stack walking API, I had a play with that this week because I thought I should probably put some error handling into my application. The stack walking API, let's have a look. I'll show you. I haven't really played with it properly, so do bear with me a bit, though. You can have a stack walker, and then you can walk your stack. You give it some function. and this gives you a stream. And then you can do something. So, and note that I'm not having to get the stack trace from an error or anything. I can pick up my stack trace at any point in the application. And what this lets me do is I can do things like I can use the power of streams to find, for example, let's say the first place in the stack which has a particular package name, or how deep is my stack? How deep is my stack? I won't start singing. Or you can use the full power of the Streams API to have a look at your stack. And of course, the point here as well is that it's done lazily. So because of course everyone knows stack traces are really expensive, if the stream operation is not applicable, you're not going to incur that cost. So this is quite nice. I haven't had a chance to play with it properly, but I think this is going to be really useful under certain circumstances. In particular, I wanted to see where is the first place in the stack where my package name might be available. So, or how deep is the bit where my packages are in there. Oh, my time's up. Nearly finished. Multi-release jar files. This is really exciting for me as someone who worked on library development stuff. In the future, from Java 9 onwards, as a library developer, I will be able to release a jar file which makes use of Java 9 functionality if you're using Java 9, otherwise makes use of pre-Java 9 functionality. And it will work for 9 and 10 and onwards, or pre-Java 9, as far as I'm aware. So, for example, I don't know if this is going to happen, RxJava could, for example, release a single jar file where it uses the Java 9 Reactive Streams API if you're using Java 9. Otherwise, it uses the Reactive Streams API if you're not using Java 9. And I think this will be really useful, especially for migrating to Java 9 stuff. Process API updates. You can now get the PID of your process and kill it if you want to. This is a good thing. There's a bunch of other stuff in there as well. So if you are managing your own services, if you're creating your own microservices, you can do things like actually use command line tools in a really useful way. Updated deprecation. You'll see this when you read the documentation. You'll be able to see whether a deprecated method is scheduled for deletion or whether it's just you probably shouldn't use this. And you'll also see when something was deprecated, like Java 1.8 or 1.2 or whatever. HTML5 JavaDoc. If you generate JavaDoc, which most of us don't, you can generate it in HTML5. Yay! JavaDoc search. Look, a little search bar in JavaDoc. It's freaking brilliant. The REPL, thank God, I don't have time to look at the REPL, but there's a tutorial here. I've talked about it in some of my other talks as well. If you are used to using a REPL and you have ideas of how a REPL should work inside an IDE, please tell us, because we really want to understand what users want from the REPL. I'm sorry, I'm enormously over time. I'm so sorry. The pain of Java 9. Your code might break with Java 9. It's true, your code might break, especially if you're using Gradle. They are working on it, by the way. They are going to get it fixed, but at the moment it doesn't work. But the best thing to do is just try it out as soon as possible. Find out what the problems are, especially if some of the problems actually aren't your fault and are someone else's fault. You need to be able to report it to those libraries or to the JDK team or to whatever. So please use it as soon as possible and find out what the problems are. There's a bunch of stuff which is going away. That's one of the reasons why stuff is going to break. And there's a bunch of stuff which is going to change. For example, G1 is now the default garbage collector. I don't think that's going to have a massive impact, because I think if you care about garbage collector, you've already tuned it to within an inch of its life. And if you don't care about it, it's probably not going to make any difference. Things like, the new version string scheme. It's now Java 9, not Java 1.9. So if you're parsing the version string to figure out whether you're running on 1.8, 1.6, 1. Whatever, you're going to fall over when you parse Java 9. Okay, so be aware of that. And other stuff. Java 9 is still evolving, including IntelliJ IDEA, so these features are evolving and things are getting better, but it needs feedback from real developers to really help that happen. You don't have to modularize your whole code base in order to use Java 9. In fact, I would recommend probably not doing that unless you absolutely have to. It might not be for you. It's a non-trivial thing to modularize your code base, but you don't have to, so don't panic about it. It's fine. Reactive streams are not the same as Java 8 streams, so you have to be aware of what the different use cases are for those things. I found Java 9 encourages good design with modularity, encapsulation, so on and so forth. So it just got me thinking a lot more about architecture and design. I think this is a good thing. Encourages new ways of working with a REPL, with reactive streams. There are some different models to use. And there's lots of things in there that just make code nicer to write. So things like the collections framework, things like the stack walking API, things like the process API, all these little bits and pieces just make it a little bit nicer to write code. All the resources for this talk are available at this link, including slides, links to more information, links to all the stuff I used to try and put this thing together. And when the video is available, I will put it up on there as well too. Thank you very much.